Now, when I'm solving radicals, see this right here? This is a radical, a square root equals something. You are technically graphing this, which is the red graph right here. Can you kind of see that? And you're graphing this, which is the blue graph of 2. This is y equals x plus 3 square root, and this is y equals 2. And when you're solving an equation, what you're really doing is asking where they intersect. But you want the x value where they intersect, so the answer is 1. Now, would that be annoying to always solve by graphing? Aren't there ways you've solved equations a lot easier? And that's what we're going to use. We're not going to use graphing as a solving tool, but that's really what you're doing. You're saying, what is this graph crossing this graph? And you're trying to find the x value. For instance, if I put my answer of 1 back in, does that make sense? Does 1 plus 3 square root equal 2? Why, yes, it does. Now again, are we going to solve by graphing? No, we're going to solve with a very easy mechanism that we're going to learn today. This is just the starting point. So if we look at this page, we are doing YouTube views, an application of YouTube views. Now what I mean by YouTube views is if you have a YouTube video, on day 0, you have no views. But on day 1, after day 1, you have gotten 20 views. On day 2, you have now accumulated 30 views, so do you understand you gained 10 more views right here?
Yeah.
On day 3, you have now 35 views, which is 5 more. And do you see a pattern? I mean, do you see kind of what's going on, hopefully? Now, could these, if I said, 20 views is not much, could you have said, well, these represent thousands? Could that be 20,000, 30,000, 35,000? If you think the views are big, whatever. Now, let's graph this. Let's graph this data, and I'm going to show you something that's important and how it relates to the topic. So if we graph this, the first one's 0, 0. The second one is 0, 20. At 1 it's 0, 20. At 2, it is 30. At 3, it is 35. At 4, it is 37. Do you guys notice a square root graph? Now, I have a square root graph there. Would you think YouTube videos tend to make this square root graph a lot? Yeah. Are they popular and then they start petering off? But would this graph always be growing on a YouTube video? Would someone sooner or later watch it again? Would it keep getting bigger and bigger? It's really slow?
Yeah.
But right at the beginning on a YouTube video, it's really, really popular sometimes, and then it peters off. Not all videos are like that. Sometimes they do all sorts of stuff. But a lot of things in life grow really quick and then they get old. Kind of like fads. Have you ever had fads that do that? Get really popular and then they fade off. Same idea. Something gets really popular, then it gets not so popular. Now, why does that matter? Well, that's an application of a square root graph. Anything that grows quickly and then kind of fades away. But they're still values, they just slowly grow because less and less people do it. Okay, now why is this graph important? Well, let's solve it. How would you find out on what day you got 50 views? What day you got 50 views? Well, could you make the equation for that graph? And if I want 50 views, aren't we looking up here? Don't we look when that graph would hit 50? Now, my graph's not big enough to see that, but if I could make an equation and solve it, I could find out how long it would take to get 50 views. Okay? Could I also use this graph to see how many views I might have after 8 days, if this pattern continued? Could I predict 8 days worth of views? Yeah, could you go up maybe about 43? If my pattern kept going, I'd have 43 views now by then. If my graph was still consistent. So you can predict when it's going to be like out of 50, or you can plug numbers in and look at it to see what you might have at certain days. That is what's useful about equations, graphs, and solving kind of relates to all this together. But just, and again, square root graphs tend to be graphs that grow really quick and then start losing interest. They kind of slow down growing. What's really important is to look at this right here. when we have fractional powers and radicals, you need to know how to go back from a radical to a fractional power, and from a fractional power back to a radical. Do you see our radicals here? I'm going to convert them to fractional powers. See our fractional powers here? I'm going to convert them into radicals. Being able to go back and forth is an essential tool in rewriting radicals, and it leads to solving radicals later. So let's talk about this. I want to rewrite this as a fractional power. So this is going to be x to some power. Now, what you look at when you see this formula is what you'll notice is the root is the number in the radical. That root will always be at the bottom of the fraction. Think of it as underground. Isn't this like ground? Aren't roots underground? So the 3 is always going to be on the bottom. The radical root is always on the bottom, and the other number is going to be on top. So again, the radical root is always underground, and the other piece is at top. Can I reduce this fraction?
No.
No. So we're done. Let's go to the next one. I have x to a fractional power. The 15 or the 6 is, which is the root? Isn't it the 15? Mm-hmm. And don't roots go in the denominator? So that would be a 15 there, and the 6 goes here. Can you reduce this one?
Yes.
Why, yes, you can. So if you reduce it, this will be x to the, well, what goes into 6 and 15? Doesn't 3? 3 goes into it. Wouldn't that leave you 2 and 5? Wouldn't that be the simplified fractional power of it? Just remember, we always reduce fractions. Is this a fractional power that's equivalent? Yes, but this is the reduced. We just always reduce fractions. Last one. When I look at this one. Wait, there's nothing here. What is it when it's missing a number here? 2. You have to understand there's really a 2 hiding there. Because it's called a square root for a reason. It's called a square root. So what we have here is x. So what number is down here? The 2 that wasn't there that I put on to help me. And then I put the 7 at top. And does 7 over 2 reduce?
No.
No. We are done with that one. Now, for these 3, we're going to make them into radicals. But before we make them into radicals, I need to reduce fractions. So 2/5 is reduced. So that's going to be fine. Put the x here. All right. And the 5 is the root. So the 5 is going to go here. So the 2 will go in the other spot. So that will be a 5 there and a 2 there. Done. Let's go to the next one. Does 10/4 reduce?
Yes.
Ooh, yes. I need to reduce that. What goes into both 10 and 4? It looks like 2. So I could go 2 goes into 10, leaves you a 5. And 2 goes into 4, leaves you a 2. Now, can I break that down? Yes. As a radical, let's see what that gives you. Well, I have a 2 on the bottom. Do I have to put a 2 there? Could you? Yes, kind of awkward, but you could put it there. The 2 does go there, but it's a square root. You don't need it. But the 5 does have to go there. So that would be your answer for that one. You had an extra step because of the reducing, and then that is a square root. You could put a 2 there. Next, 2/8. That does reduce. 2/8 reduces to 1/4. All right. Now, that is going to be the 4 is going to be your root. So the 4 goes there. And do I have to put a 1 there? No, you don't need the 1 there because that's kind of, again, awkward. But you could put it. You could put a 1 there, but that would be your radical form. So make sure you know how to go from radicals to fractional powers and fractional powers to radicals. Good luck with that. So I'm going to solve these radicals. Now, a lot of you could just look at it. Some of you could look at this and just see the square root of what is 6, and some of you know it's 36 by looking. But technically, how do you undo a square root? To undo square roots, you square. Just like undoing minus, you add. To undo a square root, you square both sides. So when you undo that, that becomes x. 6 squared is 36. And there's my answer. When I plug in 36, do you get 6? Is the square root of 36 6? Yes, it is. We're good. Check mark. But look at this next one. Some of you might tell right off the bat it's impossible, because you can never square root something and get a negative 6 out. Watch. If I square both sides, won't that be x equals 36? But here's the problem. When I plug 36 back in, does the square root of 36 equal negative 6? No. That is not equal to it. So this is called no solution. What would have been the solution is 36, but when I plug it in, it doesn't work. There's an error. So 36 is called extraneous. It does not work. So you have to watch out for that. Okay, the next one. How do you get rid of a cube root? Well, couldn't you cube it?
Yeah.
So could I cube both sides? That leaves me x equals 2 cubed, which is 8. And if you plug 8 in, is the cube root of 8 2? Yes, it is. So 8 is a good answer. This one, if I cube to get rid of the cube root, I get x equals negative 2 cubed is negative 8. Now this you might wonder, okay, is this also extraneous? Let's check. If I put negative 8 right there, the cube root of negative 8 is that negative 2. Now for some people, that might be a little hard to verify because you just still struggle. What's that saying exactly? But that is a true statement. You are good, so that is okay. Basically, just remember, if you are square rooting something and you get a negative out, there's an error. If you cube root something and you get a negative out, you're fine. But you can always plug in and check. So for this problem down here, you have to understand a half power is a square root. So these problems are very basically identical. You could think of this as the square root of x equals 5. But also, couldn't you just square? Watch what happens when you square both sides. Because to get rid of a square root, don't you square?
Yeah.
Or to get rid of this, couldn't I just square this? If I take a half times 2, what is 1/2 times 2? Isn't that 1?
Yes.
And 5 squared is 25. There's my answer. If you plug it in, it'll be fine. You would see that it works. For this one, how do you get rid of a 1/3? Well, if I cube both sides, watch what happens. Won't 1/3 times 3, 1/3 times 3, doesn't that mean I have a whole? If I have 3/3, isn't that a whole?
Yes.
So that gives me x equals 5 cubed, which is 125. If you plug that back in, you will see it works. Next, right here. How do you get rid of a half? Well, I square it, because a half is a square root. That gives me x equals negative 5 squared is 25. But here's the problem. Does that work? If I put 25 back in here, 25 square root, remember it's half power is the square root. That doesn't make any sense. So there is no solution here. This one's a no solution. Because you cannot have a half power, which is a square root, equaling negatives. Can I have a cube root, or 1/3 equaling a negative? Yes, I can. So if I cube this, I get x equals negative 125. And if you plug that in, you would get the cube root of negative 125, that's a negative, sorry, equaling negative 5, which is true. So you're good. Remember, a 1/3 is a cube root. If you want to change it to a cube root, you could, or you can just understand that multiplying 1/3 times 3 is 1. Either way works perfectly fine. So if I want to, on this problem, I want to find the value of this. Then I'm going to find the value of this, and then we're going to solve, and answers are going to end up looking kind of like this, you'll see. So to solve this, here's how I like doing it. What I like to do is I see the root is a 3. Okay, my root's a 3, it means a cube root. So what I do is I look inside and think, okay, is this something to a third power? And it is. Isn't negative 8 negative 2 to the third power? Now, kind of look what I just did. Do you see how I still have a third power, but I changed negative 8 to be negative 2 cubed? I made it negative 2 cubed, so I changed the way it looks. So, now, can't you multiply the powers? What do you get when you multiply 3 times a third? Doesn't it give you 1? 3 times a third, doesn't it give you 1?
Yes.
So what you should notice here, isn't this going to be negative 2 to the first power? And what's negative 2 to the first power?
Negative 2.
Negative 2. There's my answer. I just figured it out. Let's try it again. This right here equals negative 2. Let's try this one. Now with this one, I want to rewrite 25 so it has a power of 2, the root. The root is 2, so I want my power in here to be a 2. So I want there to be a 2 power here. So what can I read? 25, so it's squared. What squared gives you 25? Because I want that 2 to get rid of.
5.
Yes. Isn't 5 squared 25? So I'm trying to make 25 into something to a second power so it matches the root. So are we okay? There's a 5 squared. That equals 25. Now, if you look at the powers, if I have 2 times 3 over 2, now that might confuse you a little bit. 2 times 3 over 2. Can you tell that's 3? Well, if you can't, watch this. 2 times 3 over 2. Now, let's look at that. 2 times 3 over 2. Isn't there a 1 hiding underneath that 2?
Yes.
And if you multiply straight across, don't you get 6 over 2? Which, when you reduce, is 3. Now, some of you can just see the 2's cancel, leaving you 3. It just depends. Just understand, the whole point of making this and this match is so they disappear, leaving you just the numerator. So what I now have is 5 to the third. And 5 to the third is 125. So this right here is really 125. So let's recap. We keep the outside power, but we look at the inside and think, okay, I need something to a second power. So how can I change this to a second power? Over here, I needed a third power, so I change what's inside to a third power. Once you do that, these will cancel, leaving you third power. Those will cancel, leaving you 1 power. This is an essential way to find values with this. So, if I want to solve this, I want to turn this x into x to the first. So what could I power this by so I get x, or x to the first? And what you would notice is, if you take a power to the reciprocal power, meaning, what's the reciprocal of 2/3? 3 over 2. Now look at that. If I take a 3 over 2 power of this, won't that become 6 over 6, which is 1? So if I do the reciprocal power, will I drop off the power and have x to the first, or x? But don't I have to do that to both sides? So what I now have is 4 to the 3 over 2 power. But here's my problem. 4 to the 3 over 2 power. Now am I doing a problem like this? Did you catch that? Now I got to do these things. So I need to change 4 to a second power. So couldn't I write that as, okay, I still have 3 over 2 power, and I want a second power here. So what to the second power gives you 4? I need to change that inside. 2. Isn't that a 2 here? Doesn't 2 squared equal 4? Won't the 2's cancel? Leaving me 2 to the third? Don't the 2's cancel, leave me a third here? So it's 2 to the third. And what is 2 to the third? 8. Could I plug the answer in? 8 to the 2/3 power, does that equal 4? Now that might take some work, but are there any negatives that would malfunction this? No. If you broke this down, if you solved this, could you come to 4 maybe and check it? Using the same process I did here? Meaning, could you make this 2 to the 3rd to the 2/3 equal 4? And what you're going to check is you're going to find out it works. Because the 3's will cancel, leaving you 2 squared, which is 4. So 8 is the right answer. Okay, to solve this, I have to power both sides by the reciprocal of the power. So I'm going to power it by a 2/3 power. Because if I do a 2/3 power, this will become 1. But I still have a negative 8 to a 2/3 power. I now have to figure out what that right there equals. In order to find out what that equals, I have to keep the 2/3, but don't I want a 1/3 power right there? I'm sorry, a 3rd power. So what would that be right there? What negative 8 is what to the 3rd? Isn't that a negative 2? Okay. Negative 8 is negative 2 to the 3rd. Won't the 3's cancel? That leaves you negative 2 to the 2nd. And what is negative 2 to the 2nd? Negative 2 to the 2nd is 4. But here's a problem. When you plug that in, it doesn't work. Watch. If I take 4 to the 3/2 power, does that equal negative 8? Now, could you take the time to try to solve that? Yes, but how would a 4 ever end up as a negative when you're taking powers? There's no negative to start with. How would you end up with a negative? It's impossible. So for this one, this 4 would never turn out to be that. So this is no. So this is not the solution. This is a no solution. Make sure you start checking your answers. Some of you are too lazy to check your answers, and you'll find you'll miss problems because you don't check it. Please check. Alrighty. So if I want to solve this problem right here, I have to get rid of this 1/2 power. To make a 1/2 power into being gone, you have to power it by the reciprocal, which is a 2/1 or the 2nd power. So if I take this to the 2nd power, our power is gone. But we have to do that to both sides. So this becomes a x minus 2 over here. And on the right is 6 squared, which is 36. So if I take a 1/2 power and I square it, this disappears to a 1. And this becomes a 36. And that is a very, very simple solve from there. You simply add 2 over. So x equals 38. Now, should you check it? Let's mentally check. What's 38 minus 2? Does 38 minus 2 to the 1/2 equal 6? Yeah, that's 36. Isn't that a square root? Square root of 36 is 6. We're good. So 38 is actually our answer. So in order to solve this one, I got to get this 1/3 power gone. So how do you get rid of a 1/3? If you cube it, won't that become a 1 right here? So if I cube it, that'll become a 1, so I left with x plus 5. But I also have to cube this side, and negative 2 cubed is 8. Oh, negative 8. Because negative 2 times negative 2 times negative 2 is negative 8. Then I got to minus the 5 over. So x equals negative 13. But now we got to double check, if that makes sense. So I have negative 13 plus 5 to the 1/3 equals negative 2. That, I just plugged it back in the original, put negative 13 there. What's negative 13 plus 5? Isn't that negative 8? So does negative 8 to the 1/3 give you negative 2? Well, let's think. Okay, if 1/3 isn't negative, what to the third gives you negative 8? Isn't that negative 2? Isn't negative 2 cubed negative 8? Won't these cancel? And so, doesn't that give you negative 2 equals negative 2, which is true? So we're good. Make sure you check, especially when you get negatives, check. But some of you do know cube roots can have negatives, so you would have known that. But some of you don't, and it just depends. Make sure you check your work. So for this last one, I want to get rid of the 2/3. So I have to power by the reciprocal, which is 3/2. So that becomes x plus 5. Now, what is 1 to the 3/2 power? Well, 1 to any power is 1, so that's actually kind of easy. 1 to any power is 1. Minus the 5 over. X equals negative 4. Now, is that work? Let's see. Does negative 4 plus 5 to the 2/3, will that give me 1? That's a 1, right? Will 1 to the 2/3 give me 1? Yes, it does. We're good. So none of these had errors. All of them checked, did not error out. The key for all of these is thinking, how do you get rid of this fractional power? To solve this, we don't have fractional powers, we have radicals. So how do you get rid of a square root? Well, don't you square it? I kind of like it. I like square roots and cube roots more than radical with like fractional powers. I think it's a little bit easier. But that leaves you x minus 6 right here. And 1 squared, isn't that 1? Okay, then can you add 6 over? And we have x equals 7. So let's verify. If I put 7 in, what's 7 minus 6? 1. Is the square root of 1 1? We are good. I checked it. I didn't write it, but I verbally just looked at it and checked it. We're good. For this problem right here, if you're really sharp right off the bat, could you ever have a square root equaling a negative 6? No. Done. No solution. If you're very sharp right off the bat, you should know this is no solution. But let's solve it to show why that's the case. If I square both sides, I get x plus 4 equals 36. Then I minus 4 over. So I get x equals 32. When I plug in 32, watch what happens. 32 plus 4, does that equal negative 6? No, it doesn't. How can you have a square root of 36 equaling negative 6? This is not an answer. There is no solution to this one. No solution. For this one, oops, I don't want that. For this one, let's do it here. For this one, I want to get rid of the cube root, so I'm going to cube both sides. Now, to get rid of the cube root, I cube both sides. So that leaves me x minus 5 here. And if I cube a negative 4, that becomes a negative 64. Add 5 over. X equals negative, not 60, but 59. Now, some of you might have thought, well, negative, it's not working. No, on a cube root, you can have negatives. So you have to kind of watch out for this one. This one, you could have known from the beginning, you can't square root and get a negative, so you could have jumped without doing any of this. But for this one, you have to keep going because it's possible. Watch it work out. If I do the cube root of negative 59 minus 4, does that equal negative 4? Does the cube root of negative 64 equal negative 4? Why, yes it does. So that works. Now for this one, before I can cube both sides, I got to get rid of that 7. How is the 7 connected? Well, it is multiplied on. So to get rid of a multiply, you divide by 7. Those are gone. So I now have the cube root of x plus 1 equaling 3. How do I get rid of a cube root? Now I cube. So I now have x plus 1 equals 3 cubed, which is 27. Now, how do you get rid of that 1? You minus it off. So I have x equals 26. Now, if I plug 26 right here, plug 26 right there, 26 plus 1 is 27. The cube root of 27 is 3. 7 times 3 is 21. My check is good. Do I have to write the check? No, I could do it just as looking at it. The check does not have to be written. Right here, I want to solve this one. In order to get the square root by itself, before I square anything, I have to get this by itself. So we can get rid of the 2 or the 3 first. Well, if you think about basic solving, we always get rid of these first. Just any kind of solving, you always add, subtract first. Now, before I get rid of this square root, I got to get rid of that 2. It's connected by multiply, so I divide off. So I now have the square root of x equals 5. Now, could you square both sides? Yeah. Or can most of you just look at that until it's 25?
Yeah.
You can square both sides, or you could just look at that and see, oh, my answer is 25. It's your choice. Now, let's verify. Let's put 25. Is the square root of 25 is what? 5. Is 2 times 5 is? 10. 10 plus 3 is 13. I mentally checked it. We are good.